McDonald's serves over 70 million customers worldwide, according to Statista.
If an Egg McMuffin sounds good to you, listen.
And for millions of Americans, breakfast starts with one simple favorite, the Egg McMuffin. It looks identical in every restaurant, perfectly round, warm, and golden. But have you ever heard the rumors about whether these perfectly round eggs are even real? So what's the truth behind them? Let's take a closer look. Inside massive food factories, stainless steel mixers, tunnel ovens, and automated egg machines work around the clock to create its key ingredients. Each part is engineered for speed, safety, and consistency. So how do factories make the same muffin, bacon, and egg taste exactly alike across thousands of stores? The Egg McMuffin was invented in 1971 by Herb Peterson, a McDonald's franchise owner in Santa Barbara, California. He wanted to create a breakfast item that people could eat with one hand while driving to work.
If you think they sound good, they've got sizzle in the middle.
Inspired by Eggs Benedict, Peterson designed a simple sandwich with a toasted English muffin, a round egg, Canadian bacon, and melted cheese. At first, McDonald's headquarters was unsure about serving breakfast at all. But once it launched nationwide in 1975, the Egg McMuffin became a morning sensation and helped establish McDonald's breakfast as a new daily ritual in America. It also changed how fast food chains viewed early morning dining, leading to an industry now worth billions each year.
At McDonald's, we do it all for you.
For many Americans, the Egg McMuffin isn't just food. It's a familiar taste of morning routines and commutes. But how do factories make its key ingredients look and taste identical in every restaurant? The process begins with the English muffin, the foundation of the McMuffin's soft yet crispy texture. Inside stainless steel mixers, workers combine wheat flour, water, yeast, sugar, salt, and a touch of oil. Each batch weighs about 300 pounds and is mixed for several minutes until smooth and elastic. The dough is then sent to proofing chambers where controlled humidity and warmth allow the yeast to create tiny air bubbles. This step gives the muffin its fluffy structure. After rising, automated cutters divide the dough into perfectly sized rounds, slightly flattened and dusted with cornmeal to form the signature golden base. The pieces move through a tunnel oven nearly 100 feet long, where they bake at around 400 degrees Fahrenheit for several minutes. Cooling conveyors guide them to slicing machines that cut each muffin precisely in half. The air fills with the smell of warm bread, and thousands of muffins roll down the line every hour. Each one looks nearly identical, ready for freezing and shipment to McDonald's kitchens nationwide. How does the next savory layer, Canadian bacon, get its perfectly round shape and smoky taste? In another facility, lean pork loins are transformed into the signature round slices of Canadian bacon. Workers trim off fat and connective tissue before the loins are shaped into uniform cylinders. Each piece is placed into a stainless steel tumbler that rotates slowly, coating it with a curing brine made of salt, sugar, and natural flavorings. This mixture helps preserve the meat while adding moisture and color. After marination, the pork is loaded into steam ovens or smoke chambers, depending on the recipe. Inside, the temperature climbs to about 160 degrees Fahrenheit, fully cooking the meat while maintaining its pink center. Some plants use natural wood smoke to create the gentle aroma familiar to every McMuffin fan. Once cooled, slicing machines cut the loins into paper-thin, perfectly even rounds. A single machine can slice thousands of pieces per minute. The slices are then stacked, sealed in vacuum packs, and stored at 35 degrees Fahrenheit until delivery. Each pack is tested for weight, texture, and appearance before shipping. But what about the most important ingredient, the real egg that gives a sandwich its name? Factories that supply eggs to McDonald's receive deliveries straight from local farms every day. The eggs are washed, inspected under bright lights, and sorted by size. Workers crack fresh grade A eggs directly onto a flat griddle, heated to about 300 degrees Fahrenheit, 149 degrees Celsius. Each egg is cracked into a round metal ring that holds its shape while cooking. A small amount of water is added, and the eggs are covered with a hinged metal lid, allowing steam to gently cook the whites through without browning. Once cooked, the rings are lifted manually with a handed tool, and the cooked eggs are transferred to heated trays, where they are held warm until assembly. The result is the familiar round white and yellow disc that perfectly fits inside the sandwich. Quality inspectors test random samples for protein levels, color, and freshness. Have you ever noticed how the egg in every McMuffin looks exactly the same? That uniformity starts long before it reaches your breakfast tray. The creamy slice of cheese in the McMuffin starts in large dairy processing tanks. Milk, whey, and natural cheese solids are blended with emulsifiers that help the cheese melt smoothly. The mixture is heated to more than 180 degrees Fahrenheit, while being stirred continuously until it forms a thick, uniform paste. The molten cheese is then poured onto chilled steel rollers that flatten it into thin, flexible sheets. These sheets are cooled and trimmed by automated cutters into perfect 4-inch squares. Each slice is layered with thin wax paper to prevent sticking. The packaging area maintains a temperature of 40 degrees Fahrenheit to preserve quality. Machines stack the slices in groups of 12, seal them in airtight plastic, and prepare them for refrigeration. The cheese's exact melting point is carefully engineered, allowing it to soften just enough without dripping during assembly. This ensures that every McMuffin has the same creamy texture in every bite. Now, once all the parts are made and packaged, how do they travel across the country while staying fresh? All 4 components, the muffins, bacon, eggs, and cheese, are stored in refrigerated warehouses before shipment. Cold chain logistics play a crucial role here, keeping every item below 40 degrees Fahrenheit, from factory to restaurant. Distribution centers coordinate deliveries daily, using temperature-controlled trucks to reach more than 13,000 McDonald's locations in the United States. Inside each store, staff follow a strict 2-minute assembly routine. The muffin is toasted in a high-speed conveyor toaster. The bacon is grilled briefly on a flat top, the egg is reheated on a warm plate, and the cheese is added last to melt gently between the layers. The final sandwich is wrapped in foil-lined paper to lock in heat and moisture. Each McMuffin is identical in look, weight, and temperature before it leaves the counter. It's a process where industrial precision meets everyday breakfast comfort. But the question remains, how did a simple breakfast sandwich become one of the most replicated fast food items in the world? Americans eat over 20 billion hot dogs every year, according to the National Hot Dog and Sausage Council. That's about 70 hot dogs for every person in the country. From backyard barbecues to baseball stadiums, this simple sausage has become one of the most recognizable foods in American culture. But behind that familiar snap of the first bite lies an enormous production system running day and night. Inside modern factories, machines can fill and cook thousands of hot dogs every minute, each one perfectly smooth and identical in size. So how do companies turn raw meat into millions of ready-to-eat hot dogs that taste exactly the same? The story of the American hot dog begins in the 1800s, when German and Austrian immigrants brought their sausage-making traditions to the United States. By the 1860s, vendors in New York were selling dachshund sausages from street carts, often served in bread rolls for convenience. The name hot dog became popular in the early 1900s, around the same time baseball stadiums began selling them as quick, affordable snacks. During the 20th century, brands like Oscar Mayer and Nathan's Famous turned the hot dog into a national icon by introducing automated production lines that could make thousands per hour. The invention of refrigerated trucks later helped distribute them nationwide. Today, hot dogs are a staple at cookouts and sports events, symbolizing summer and nostalgia for many Americans. But how do factories transform simple meat trimmings into those smooth, perfectly shaped sausages we see in every grocery store? The journey of a hot dog begins with meat selection. Factories receive large shipments of beef, pork, or poultry from inspected suppliers. Each batch is checked for temperature and freshness before unloading. Skilled workers trim off excess fat, bone, and connective tissue. The meat then moves into massive stainless steel grinders that break it into fine pieces. Each grinder can process over 5,000 pounds per hour, creating a uniform texture. Cold water or crushed ice is added to maintain a safe temperature below 40 degrees Fahrenheit, preventing bacteria growth. The sound of the grinders fills the room as meat flows through conveyors into large blending tanks. Quality inspectors test random samples for fat-to-protein ratio to ensure consistency. This step sets the base for the signature smoothness every hot dog has. Once the meat is ready, it's transferred to mixing machines for seasoning. But what gives hot dogs their classic salty, smoky flavor that Americans have loved for over a century? Inside the blending room, the freshly ground meat is combined with precise amounts of seasonings. Typical ingredients include salt, paprika, garlic powder, and coriander, along with curing agents such as sodium nitrite. Each addition has a purpose. Salt enhances flavor, paprika adds color, and nitrite helps preserve freshness while giving hot dogs their pink color. As the mixtures spin, they maintain a cool temperature to protect texture and flavor. Ice flakes or chilled water keep the mixture from overheating. After a few minutes, the meat turns into a thick, sticky paste. This emulsion is what gives hot dogs their smooth, elastic texture instead of a coarse grind like regular sausages. The mixture is then checked for pH and consistency before moving to the stuffing room. How does this soft pink paste suddenly transform into perfect rows of sausages ready for cooking? In the stuffing area, the emulsion is pumped through long tubes into thin casings that shape each hot dog. Decades ago, these casings were made from animal intestines. Today, most factories use cellulose casings made from plant fibers. They are clean, smooth, and can be peeled off easily after cooking. High-speed stuffing machines work at incredible speeds, filling and twisting up to 3,000 hot dogs every minute. The continuous chain of sausages moves along a conveyor, twisting automatically into individual links. Operators monitor pressure and diameter to ensure every piece is the same size. The long chains are hung onto stainless steel racks, each carrying hundreds of hot dogs at once. The smell of spices becomes stronger as the racks roll toward the next area. These racks are then transferred into large ovens or smokehouses for cooking. But how do factories make sure every hot dog is fully cooked and safe to eat before packaging? The racks of hot dogs enter giant smokehouses, where heat and smoke give them flavor and color. Inside, the temperature slowly rises to about 170 degrees Fahrenheit, ensuring the meat cooks evenly without drying out. Some factories use hickory wood chips to create a smoky aroma, while others inject controlled steam to maintain moisture. Fans circulate hot air, keeping the temperature uniform across thousands of sausages. After about an hour, the hot dogs are fully cooked and ready for casing removal. The racks move to the peeling machines that spray them with cool water and slice open the cellulose casing. High-pressure rollers then slide the skin off cleanly, revealing the shiny surface of the finished product. Workers check the color and firmness before sending the hot dogs to the cooling area. The smell of smoke fades as the room fills with the sound of conveyor belts and peeling machines. Now that the hot dogs are cooked, how do factories preserve their freshness for shipping across the country? After cooking, the hot dogs pass through a chilling system that uses a mix of cold water and air to bring the temperature down quickly. Cooling from 170 degrees Fahrenheit to below 40 degrees Fahrenheit takes only minutes in modern plants. Once firm, the sausages travel down conveyor belts to packaging machines. Automated sorters count and group them, usually in packs of 8 or 10. Inspectors stand along the line to remove any that are bent or misshapen. Vacuum sealers then wrap the hot dogs in airtight plastic to lock in freshness. Some factories flush the packaging with nitrogen gas to prevent oxidation. Finally, the sealing packs are boxed, labeled, and stored in refrigerated warehouses, awaiting shipment. From there, trucks deliver them to supermarkets, ballparks, and restaurants nationwide. Each pack has a code that traces it back to the exact production line and day it was made. So next time you fire up the grill, you'll know that every hot dog started its journey through stainless steel, steam, and precision timing. Americans consume nearly 1.3 billion gallons of frozen desserts each year, according to the International Dairy Foods Association. Among them, one stands out for its creamy texture and unmistakable taste: the Frosty. First introduced by Wendy's in 1969, it became an instant favorite for being thicker than a milkshake, but softer than ice cream. Yet few people know that the Frosty's signature texture doesn't come from the restaurant's machine alone. It starts much earlier inside large dairy processing plants, where milk, sugar, and cream are transformed through precise temperature control and aeration. So how do factories create thousands of gallons of this smooth dessert that melts so slowly and tastes so consistent? The Frosty was created in 1969 by Wendy's founder Dave Thomas, who wanted a dessert that was richer than a milkshake but softer than traditional ice cream. He worked with dairy suppliers to develop a mix that balanced chocolate and vanilla flavors, producing a smooth texture that could hold its shape in a cup. At first, the Frosty was served only in one size and one flavor, and it quickly became a signature part of the Wendy's menu. Its formula was unique, lower fat than ice cream, but aerated to feel creamy and dense at the same time. Over the years, the Frosty inspired countless imitations and new flavors, including vanilla and strawberry, but the process behind it stayed nearly the same. Today, large dairy factories produce thousands of gallons of this mix every day. The process starts with milk, cream, and sugar delivered to the factory in large refrigerated tank trucks. Each ingredient is tested for purity and temperature before unloading. Inside stainless steel mixing tanks, workers pump in the milk and cream while agitators begin to stir slowly. Next, dry ingredients like whey powder, cocoa, and flavoring are added through the automated feeders that ensure precise measurement. Stabilizers and emulsifiers such as guar gum and carrageenan are also blended in. These keep the texture smooth and prevent ice crystals from forming later. The tanks are chilled to around 40 degrees Fahrenheit, keeping the mixture safe and fresh as it blends into a thick, creamy base. Powerful mixers spin for nearly 20 minutes, creating a uniform consistency ready for pasteurization. Sensors check the density and sugar content of each batch before it moves forward. The sweet scent of milk and cocoa fills the air as thousands of gallons flow into waiting holding tanks. But how do factories make sure this creamy mixture is both safe and stable before frozen? The base mixture is heated in pasteurization systems to kill any bacteria while preserving flavor. The liquid travels through stainless steel pipes into plate heat exchangers that raise its temperature to 175 degrees Fahrenheit for 15 seconds. Immediately afterward, it is cooled back down to below 40 degrees Fahrenheit. This fast heating and cooling process guarantees food safety without changing taste. Next comes homogenization. Under pressure as high as 2000 psi, the mixture is forced through narrow valves that break down fat molecules into microscopic droplets. This keeps the mixture smooth and prevents separation when frozen. Once homogenized, the product is transferred into large aging tanks. It stays there for several hours at a constant 36 degrees Fahrenheit, giving time for the proteins and stabilizers to fully hydrate. The result is a thick, velvety base that will freeze evenly in the next stage. Workers test small samples for texture and viscosity using lab instruments. But how does this cold, liquid mixture transform into that fluffy, spoonable dessert we all recognize? This step gives the Frosty its unique texture. The chilled mixture enters a continuous freezer, where it is partially frozen while air is whipped in. Known as aeration, this process controls how light or dense the dessert will feel. The temperature inside the barrel drops to 19 degrees Fahrenheit, while blades spin at hundreds of revolutions per minute, scraping the frozen layer from the walls. The constant movement prevents large ice crystals from forming, keeping the texture soft and smooth. Air pumps inject a precise amount of clean, filtered air into the mix, usually about 40 to 50% of its volume. More air means a lighter, creamier mouthfeel. Technicians check the overrun, or the percentage of air, using a density gauge. Each batch must match exact standards so that every Frosty tastes identical nationwide. The partially frozen product now looks like soft-serve ice cream, thick but still pourable. So what happens next to keep this texture perfect during transport? The semi-frozen dessert is pumped through insulated pipes into high-speed filling machines. Each filler dispenses the mix into sealed plastic bags or wax-lined cartons sized for restaurant dispensers. The machines work fast, filling hundreds of packages per minute while maintaining the mix's cold temperature to prevent melting. The filled containers are immediately placed into blast freezers, where powerful fans blow air at minus 40 degrees Fahrenheit. Within minutes, the temperature of the dessert drops below negative 20 degrees Fahrenheit, locking in its texture and flavor. Workers stack the frozen packs on pallets and move them into large cold storage warehouses. Each lot is tracked by barcode for traceability, ensuring it can be traced from factory to restaurant if needed. The frozen bags are now ready for transport through refrigerated trucks that maintain a temperature below 0 degrees Fahrenheit throughout the journey. Well, what happens when these frozen mixes finally reach the restaurant? At the restaurant, workers load the sealed bags into a soft serve or Frosty machine. The equipment gently warms the mix to about 26 degrees Fahrenheit, then churns it continuously to maintain its creamy texture. Inside the freezing barrel, air is whipped in one final time to create the perfect density. As the machine dispenses, the dessert flows out in smooth ribbons, forming that familiar swirl into each cup. Every serving has the same temperature, texture, and flavor, no matter where you buy it. Technicians regularly test the mix to ensure it stays within strict food safety limits. The result is a dessert that feels cold but never icy, thick but never heavy. It's the same Frosty that Americans have enjoyed for more than 50 years, a carefully engineered balance of air, dairy, and temperature. Have you ever wondered how something so simple could depend on such exact science behind the scenes? From sizzling grills to freezing tanks, every product we explored today, the Egg McMuffin, the hot dog, and the Frosty, shows how everyday foods are shaped by modern engineering. Inside these factories, precision replaces guesswork. Machines bake, mix, and chill with perfect timing, creating the same taste and texture millions of people enjoy every day. Each product tells a story of innovation that connects our childhood memories to the world's most advanced production lines. Whether it's the smell of toasted muffins, the sound of sausages steaming, or the cold swirl of a Frosty, these details remind us how industry meets comfort. The next time you eat one of these classics, you'll know the journey behind every bite. If you enjoyed this inside look, don't forget to like, share, and subscribe to Captain Discovery for more behind-the-scenes stories from the world of food production.